Ketones with carbonyl group attached to a benzene ring are also named as phenols. Aldehydes and ketones are organic compounds containing carbonyl compound. Aldehydes are the organic compounds in which carbonyl group is attached to one hydrogen atom and one alkyl or aryl group. In the IUPAC system, ketones are named by replacing the terminal E of the alkane replaced by ONE. Hello everyone, this is Ambali Unnikrishnan from the Department of Chemistry. So today I am back with a new chapter, that is chapter 8 of your syllabus, Aldehydes, Ketones and Carboxylic acid. So we have completed alcohols, phenols and ethers in the last session. Today we are going to begin with the next organic chemistry chapter, that is aldehydes, ketones and carboxylic acids. So you might be familiar with which is the functional group of aldehyde, ketone and carboxylic acid. So that basic things you might be already familiar with, but in detail we are going to study the nomenclature of these, then we are going to study the preparation, the physical and chemical properties of each one of this in detail in this chapter, right? So in today's session we are going to discuss the nomenclature of aldehydes and ketones in detail, okay? From the next session we are going to start with the preparation and chemical properties. So as an introduction, what are aldehydes and ketones? Carboxylic acids towards the end we are going to discuss, okay? Aldehydes and ketones are organic compounds containing carbonyl compound. Even carboxylic acid is the same. We'll discuss it later, okay? Aldehydes and ketones are organic compounds containing carbonyl group. So this we have already discussed. What is carbonyl group? The C double bond O you can see. This is called as carbonyl group, okay? So the carbonyl group containing compounds are called as carbonyl compounds. So your aldehyde, ketone, carboxylic acid, all of these are carbonyl compounds. So you can see in aldehyde also you have C double bond O, in ketone also you have C double bond O, okay? So aldehydes are the organic compounds in which carbonyl group is attached to one hydrogen atom and one alkyl or aryl group. So as you can see here, the structure RCOH, right? So what does it mean? In aldehyde, the carbonyl carbon, right? This is the carbonyl carbon is attached to one alkyl or aryl group. This can be an alkyl or aryl group, and another side it will be attached to a hydrogen atom. So generally it is RCHO, right? That is RC double bond OH. So this is the general format. So this R can be CH3, C2H5, any alkyl group or else phenyl also, right? Any aryl group as well. Now, ketones are the organic compounds in which carbonyl group is attached to two alkyl or aryl groups, okay? So as you can see here one hydrogen was there. In case of ketone, both of them are R. That means that both of them are going to be alkyl or aryl group. So it is RCOR. So this both R can be same, both R can be different also. So I hope what are aldehydes and ketones is clear for you. They both are carbonyl compounds. In aldehyde, the carbonyl carbon will be attached to one R and H. In the case of ketone, both will be R, right? Now, carbonyl compounds are widespread in plants and animals. They play important role in biochemical processes to sustain life, okay? They are very important in our day-to-day life also. They add fragrance and flavor to nature and constitute several pharmaceuticals. Some members of these families are manufactured in large quantities. It is used as solvents and for producing materials like adhesive, paints, fabrics, etc. So vanillin, this is a structure of vanillin, okay, which is obtained from vanilla beans. This is, of course, when we are making food, you might have heard of this, right? Vanilla, right? Vanilla essence we add. So that is an aldehyde. You can see here, CHO, it is an aldehyde. Then you have salicyl aldehyde, CHO, salicyl aldehyde, and cinnamaldehyde, which is obtained from cinnamon, right? So all of these are examples of aldehyde. So these compounds are important in our day-to-day life as well. So of course, studying about aldehydes, ketones and carboxylic acids are necessary to us, right? Okay, so moving on to the nomenclature. Again, already we know the basics of IUPAC nomenclature, right? So again, we know that there are two ways in which you can name a compound, either using its common name or its IUPAC name, right? So aldehydes. So first we are going to begin with the nomenclature of aldehydes. The common names of aldehydes are derived from the names of the corresponding carboxylic acid, okay? It is derived from its corresponding carboxylic acid. Okay, replacing oic acid of an acid by the word aldehyde. Okay, oic acid, we know that the suffix for carboxylic acid is oic acid. So instead of oic acid, we are going to write aldehyde there. That will give you the common name. Okay, so branching in the aldehyde chain, if any, is indicated by the Greek letters alpha, beta, gamma, etc. The alpha carbon atom being the one directly linked to the aldehyde group, beta will be the adjacent one, gamma will be the next one. Okay, so let's see, CH3CHO. We have to name the common name for this. So from which acid is this particular aldehyde derived from? To CH3COOH, which is acetic acid or ethanoic acid, right? We are discussing the common name. So we commonly call it as acetic acid. So acetic acid, instead of the acid, you are going to put aldehyde there. So the name becomes acetaldehyde. Okay. Now the next one is, you have benzene on which you have an aldehyde. So the common name will be benzaldehyde, right? Benzaldehyde. So this is derived from which acid? It is benzoic acid. So instead of oic acid, you write aldehyde there. So you get benzaldehyde. Clear? So it is derived from benzoic acid. The name of the aldehyde will be benzaldehyde. Now, in this case, as you can see, the aldehyde is present here, CHO. So this is your functional group for aldehyde. So the carbon atom directly attached to the functional group will be your alpha carbon atom. The first carbon atom which is attached to the functional group. The next one will be beta, next one will be gamma. So if there are other substituent present, instead of naming it 1, 2, 3, all of that, in common name we are going to use alpha, beta, gamma, etc. Alpha will be the first carbon atom after the functional group. Clear? So this is beta bromo. On the beta carbon atom you have a bromine group, right? So beta bromo butyl aldehyde it will be. Okay, so I hope it is clear. Now moving on to the nomenclature of ketones. The common names of ketones are derived by naming two alkyl or allyl groups bonded to the carbonyl group. In common system, aliphatic ketones are named after the alkyl group attached to the carbonyl group followed by the word ketone. So the simplest ketone, CH3COCH3, is also called as acetone. The positions of the substituents are indicated by the Greek letters alpha, alpha dash, beta, beta dash, and so on. Alpha, alpha dash carbons being the ones directly attached to the carbonyl group. Alkyl phenyl ketones are usually named by adding acyl group as prefix to the phenol. So let's take some examples and understand it. The first simplest ketone is CH3COCH3. Okay, so it is CH3COCH3. So this is a ketone. As you can see, C double bond O here. So this is the functional group, that is C double bond O in ketone. So on either side you have alkyl groups. So this is called as acetone. Why? Because again it is derived from acetic acid, CH3COOH. Okay, so instead of oic acid you use ketone there. So the name will be acetone. So what is the suffix here? O-N-E, right? Moving on to the next one. This will be acetophenone. Okay, this is called as acetophenone. The next one is, as you can see, CO is here. Then you have CH2, CH3 also. Okay, so you can see CH2, CH3 here and one carbon atom here. So totally 3 carbon atoms present. So it will be propiophenone. Okay, the next one is, as you can see, there are 2 aryl groups instead of alkyl groups. On both sides you are having aryl groups. This is called as benzophenone. Okay, moving on to the IUPAC nomenclature of aldehydes and ketones, which is important. So in the IUPAC system, aliphatic aldehydes are named by replacing the terminal E of the parent hydrocarbon by al. Okay, aldehyde, whichever the hydrocarbon it corresponds to, we have to remove the E and put Al there as suffix. Okay, so when an aldehyde group is attached to a ring, the suffix carbaldehyde is added after the full name of the hydrocarbon. So once we are doing the examples, it will be clear for you. In aromatic aldehydes, the functional group may be attached either directly to the ring or may be present in the side chain. The simplest aromatic aldehyde carrying the aldehyde group on a benzene ring is named as benzene carbaldehyde or benzaldehyde. The simplest aryl aldehyde is this one, CHO. So this is called as benzaldehyde. Okay. Now, however, the common name benzaldehyde is accepted by IUPAC also. Other ring substituted aromatic aldehydes are named as derivatives of benzaldehyde. So if you have, for example, a nitro group on this position, so this will be first, second and third carbon atom. So this will be 3-nitro-benzaldehyde. So you can use benzaldehyde as the parent chain and nitro will be your substituent. Okay, I hope it is clear. So let's take the few examples here. First, aldehyde. Okay, the first and the simplest aldehyde is HCHO. The common name is formaldehyde. So from where this formaldehyde comes, it is from the formic acid, right? Formic acid. Okay, so common names are derived from its acids, right? So formic acid, you get the name which is formaldehyde. So now how do you name the IUPAC name? It is from the corresponding hydrocarbon. So which is the hydrocarbon containing only one carbon atom? It will be methane, right? So it is obtained from methane. So instead of, this is your methane, instead of the E, what do you write? Al, methanol. So methanol will be the IUPAC name of the first one, right? Moving on to next one, CH3CHO. So the common name is acetaldehyde and the IUPAC name will be 2 carbon atoms. So it is eth, right? So it is ethane. Instead of E, you put al, you get ethanol. Clear? Next one, CH3CH2CHO. So you have 1, 2, 3 carbon atoms. So this will be propanol, of course. It will be propanol. Common name is propanaldehyde. Okay. Now the next one is CH3CH2CH2CHO. 2, 3, 4 carbon atoms are there. So it will be butanol and the IUPAC and the common name will be butyraldehyde. Clear? The next one is CH3 twice CHCHO. Now what does that mean? CH3 CHCHO. That means this is your first carbon atom and the second carbon atom. On the second carbon atom, you have a methyl group attached. Okay, or else you can also write it as CH3, CHCHO and CH3. So 1, 2, 3 carbon atoms. On the second carbon atom, you have a methyl group which is attached. So this is, that is the methyl group is present on the second carbon atom. So this is an iso group, right? So it is called as isobutyraldehyde. Why? Because a total of 4 carbon atoms are present. So this is isobutyl, right? So what will be the IUPAC name according to this? 2-methyl. On the second carbon atom, you have a methyl group. So this is 2-methyl and which is the principal chain? 3 carbon atoms. So it is propane, right? So 2-methyl propanol it will come. Clear? Now moving on to the next one. This is what it is. It is not benzene, it is cyclohexane, right? So do not confuse it with benzene. There are no double bonds here. So this is first, second, third carbon atom. On the third carbon atom, you are having a methyl group. So this will be 3-methyl. First write the substituent. Then what is the principal chain? It is cyclohexane, right? So cyclohexane, carbaldehyde you have to write. Okay, it is carbaldehyde. Clear? So what is the structure of this? It is CH3, CH, and on this carbon atom you have an OCH3 group and CHO. Now what is this OCH3? We have already studied this in the last chapter. It is alkoxy group, right? OCH3, it is methoxy. So on which carbon atom the methoxy is present? This is alpha, this is beta, right? On the alpha carbon atom, you are having the methoxy. So this will be alpha methoxy propanaldehyde. Clear? Because 3 carbon atoms. Now what will be the IUPAC name of it? We are going to number it 1, 2, 3 according to IUPAC. So again on the second carbon atom, you are having a methoxy group. So it will be 2-methoxy propanol. Clear? Okay, moving on to the next one, CH3, CH2, 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 CHO. Okay, so it is 1, 2, 3, 4, 5 carbon atoms. So the name will be, of course, pentanol. Clear? The next one is CH2 double bond CHCHO. That is CH2 double bond CHCHO. So you have an aldehyde as well as a double bond. So of course the aldehyde will have the more priority. So you start numbering from this side. So on the second carbon atom you have the double bond. So the common name is acrolein. And how do you name the IUPAC name? On the second carbon atom you have the alkene. On the second carbon atom you have the double bond and 3 carbon atoms means it is going to be prop. Okay. So how do you start naming this? First you write the prop, which is your hydrocarbon. Then on the second carbon atom you have the double bond. So mention that 2. then ene, and don't write ene, this instead of this e write al, so it will be prop 2 enal. Clear? By not mentioning the position of the aldehyde, it is on the first carbon atom itself. Next one is on benzene, you have 2 CHO group. So this, the common name of this is aldehyde, and how do you name the IUPAC name? It is benzene, and on the first and second carbon atom you have 2 aldehyde groups. So it is benzene 1,2 dicarbaldehyde. Okay, 1,2 dicarbaldehyde you have to name. So benzene 1,2 dicarbaldehyde. Now moving on to the next one, you have benzaldehyde here. This much part is your benzaldehyde, and you have a bromo group. Okay, so it is 1, 2, 3. On the third carbon atom, you are having bromine, right? So it will be 3 bromo benzene carbaldehyde, or else you can also name it as 3 bromo benzaldehyde. Okay, instead of benzene carbaldehyde, you can write benzaldehyde also. Okay, and the common name is meta bromo benzaldehyde. Okay, this is ortho position, this is the meta position, right? To this is the meta position, so it is also called as meta bromo benzaldehyde. Now moving on to the IUPAC name of ketones. In the IUPAC system, ketones are named by replacing the terminal E of the alkane replaced by ONE. In the case of aldehyde, it was Al. In the case of ketone, it is ONE. Clear? Now therefore, saturated aliphatic ketones are called as alkanone. The longest carbon chain is numbered to give the carbonyl carbon the lowest possible number. Ketones with carbonyl group attached to a benzene ring are also named as phenones. Okay, they are called as phenones. Some of such names have also been accepted by the IUPAC. So let's take some examples. The first one, CH3COCH3. That means it is CH3 C double bond O CH3. So this CO which is written here, it is actually the carbonyl group. Okay, so the common name is dimethyl ketone or acetone. So you have 2 methyl groups, so it is dimethyl ketone. Okay, we ended with ketone in case of common name, right? So how do you rate the IUPAC name? Totally how many carbon atoms are there? 1, 2 and 3. So it is obtained from propane. So instead of E, you are going to put ON here. So you get propanone. That's it. Instead of E, you put ONE. Next one, CH3COCH2CH3. That is, on one side you have a CH3. Other side you are having a C2H5, which is an ethyl group. So this is ethyl methyl ketone. Why ethyl methyl ketone? According to the alphabetical order, we have to name it. So it is ethyl methyl ketone according to common name. IUPAC name, it will be 2-butanone. Now why 2-butanone? On the second carbon atom, you are having the functional group. So you can either write it as 2-butanone or butane 2-on. Right. Now the CH3CO, CH2, CH2, CH3. So 3 carbon atoms are there. So this is a propyl group and you have a methyl. So this is methyl propyl ketone. And the IUPAC name, totally how many carbon atoms are there? 1, 2, 3, 4, 5. 5 carbon atoms are there. Again on the second carbon atom, you are having the functional group. So it is 2-pentanone. Clear? Now moving on to the next one, CH3, CH2, CO, CH2, CH3. One ethyl group, another ethyl group. So this is diethyl ketone. What will be the IUPAC name? From either side you can number. So 1, 2, 3, 4, 5. On the third carbon atom is a functional group. So this is 3-pentanone. Clear? Next one, CH3 twice, CHCO, CH3 twice. So this is diisopropyl ketone. So what is the structure of this actually? You have one CH3, then CH is there, attached to which you have one more CH3, right? And then you have your carbonyl group. Then you have CH, one more CH3 attached here, one more CH3 attached here. Okay, so from this what you can understand? There are 2 carbon atoms in which methyl groups are attached and both of them are iso. So that is why it is diisopropyl ketone, because it is present on the second carbon atom. So that is why it is diisopropyl ketone. Why propyl? 1, 2, 3. 3 carbon atoms. 1, 2, 3. 3 carbon atoms. Clear? IUPAC name, how will you number? Either from either direction you can number it. So it will be 1, 2, 3, 4, 5. Right. So this is going to be 2, 4 on the second and fourth carbon atom. 2, 4 dimethyl and pent will be there, and on the third carbon atom you have the functional group. It is going to be 2, 4 dimethyl pentan you will write, and on the third carbon atom the ketone is present. So that also you have to mention as 3-on. Clear? Next one is CH3CO, COCH3. So this is called as diacetyl. And the IUPAC name is butane 2, 3 dione, because 2 ketones are there. See, this is CH3, CO, CO, CH3. So this is a diacetyl. See, this is one COCH3 means what? Acetyl group, right? This is another acetyl group. That is why it is called as diacetyl. Clear? See, this is COCH3, which is one acetyl group. COCH3 is another acetyl group. Okay. And the IUPAC name, how do you name it? 1, 2, 3, 4. So on the second and third carbon atom, you are having the ketone. Okay. So it will be butane 2, 3 dione you have to write. Next one, CH3 twice, C double bond, CH, CO, CH3. So that is you have one CH3. Then you have the C double bond C, and on the same carbon atom you have another CH3. So this is the CH3 twice, C double bond, CH. You have the ketone and another CH3. So this is the structure. So how do you write the IUPAC name? So from this side we have to number because the functional group is present here, right? So it should get the lowest number. So 1, 2, 3, 4, 5. So on the fourth carbon atom you have the methyl. So 4 methyl and it is pent, right? Totally 5 carbon atoms are there. So it is pent. 3 ene. On the third carbon atom you have the double bond. Mention that first and then write where is the functional group, that is 2 on. Clear? So separately you have to write. So in the next one, as you can see, this is the functional group. Okay. Don't get confused. This is carbon atom which is present here. So you have the C double bond over here, which is the ketone. So this is alpha methyl. Now why is this alpha? This is your functional group. So the first carbon atom is your alpha. So it is alpha methyl cyclohexane. And instead of E, you put on there. Cyclohexanone. Now, how do you write the IUPAC name? Instead of alpha, you have to put 2-methyl, right? On the second carbon atom, you have the methyl group. So, it will be 2-methyl cyclohexanone. Clear? So, I hope the nomenclature of aldehydes and ketones is clear for you. So, in the next session, we are going to discuss the nature of the carbonyl group as well as the preparation of aldehydes and ketones. So, I hope the concepts that I've covered in this session is clear for you. So, that's all for today. Thank you.